Hello everyone, welcome to my channel. If you are seeing my video for the first time, do well to subscribe, like, and let me know what you think in the comments. So how do we solve this? Now we notice that the denominator is a quadratic expression, but unfortunately the expression is not balanced to be expressed as something like x plus a squared minus b squared. So for you to achieve something like this, you need to use the completing the square method, where we say square half of the coefficient of x, and the coefficient of x here is 8. So squaring half the coefficient of x, which is 8, is something like 8 over 2 all squared, which will give us 4 squared, which is obviously 16. So I'm going to write the question again. So 1 over the square root of x squared plus 8x, but in this case I'm going to add plus 16 because I want to make this a perfect squared. Then I will add plus 3. Now because I added plus 16, I'm going to subtract 16 from it to make justice to it, right? So we have the x. So this gives 1 over the square root of x squared plus 8x plus 16 can be written as x plus 4 squared, because my main aim is that I want to write the denominator in terms of this expression, right? So plus 3 minus 16 is minus 13. Minus 13 the x. So if I want to write the denominator as this expression as mentioned earlier, so I will say 1 over square root of x plus 4 squared minus, can I say square root of 13 squared. Yes, the x. So now this looks like this, right? It looks like this. So now I can use trigonometric substitution. It says whenever you have something like the integral of 1 over x squared minus a squared, you say let x equals to a sec theta, but in this case x equals to x plus 4, right? So for me to use this method now for my own question, now we say the integral of 1 over the square root of x plus 4 squared minus square root of 13 squared the x. So we say let x plus 4 equals to square root of 13 sec theta, right? So I'm going to differentiate this. I'm going to differentiate this expression with respect to theta. So we have the x equals to square root of 13 sec theta tan theta the theta. So we have the integral of 1 over the square root of, so now x plus 4 all squared. If I want to square this now, x plus 4 all squared will be the square of root 13 sec theta, right? So let me say, let's write it somewhere here. X plus 4 squared now equals to square root of 13 sec theta all squared, which will give 13 sec squared theta. So I'm going to replace it here, 13 sec squared theta minus square root of 13 squared is 13, right? It's 13. Then multiply by the x. Now my dx is square root of 13 sec theta tan theta the theta, right? So we have the integral of 1 over square root of 13, because 13 is common here. I'll factor it out, sec squared theta minus 1 multiplied by square root of 13 sec theta tan theta the theta. So from trigonometry identities, you know that tan squared theta plus 1 equals to sec squared theta. So tan squared theta equals to sec squared theta minus 1. If I transfer this one to the right hand side, I'll have sec squared theta at the right hand side minus 1 equals to tan squared theta at the left hand side, right? So I can now replace sec squared theta minus 1 with tan squared theta. So I have tan squared theta here, then multiply by square root of 13 sec theta tan theta the theta, right? So I have another rule that says square root of a times b equals to square root of a multiplied by square root of b, right? So I can write this as square root of 13 multiplied by square root of tan squared theta, right? Multiplied by square root of 13 sec theta tan theta the theta. So square root of 13 cancels square root of 13, and this will cancel out. The square on this tan squared theta cancel the square root. So we have tan theta at the denominator. Tan theta cancel out tan theta here. So we are left with the integral of sec theta the theta alone, right? So if you want to integrate sec theta the theta, what you need to do is that you need to multiply the top and the bottom by sec theta plus tan theta over sec theta plus tan theta the theta. So if you multiply out this, the top, you have sec squared theta plus sec theta tan theta over sec theta plus tan theta the theta, right? So I'm going to use u-substitution for this. I'll say let u equals to sec theta plus tan theta, so that the u will be equals to sec theta tan theta plus sec squared theta the theta, right? So we have the integral of sec squared theta plus sec theta tan theta over u multiplied by the theta. We can say the u over this equals to the u over this will give us the theta, right? So we say multiply by the u over sec theta tan theta plus sec squared theta, right? So this cancel out this, so we have the integral of 1 over u du. So integral of 1 over u du equals to ln u plus c, right? So don't forget we say u equals to sec theta plus tan theta plus c, right? So from the beginning also, do not forget that don't forget that we say x plus 4, right? We said x plus 4 equals to with 13 sec theta here, right? We say x plus 4 equals to the square root of 13 sec theta. X plus 4 is equals to square root of 13 sec theta, right? So I'm going to solve for sec theta here. Sec theta now will be equals to x plus 4 over root 13, right? So and we know that sec theta is the reciprocal of cos theta, right? 1 over cos theta is equals to sec theta, right? So and we know that sec theta is equal to x plus 4 over square root of 13. So we say cos theta is equals to square root of 13 over x plus 4, right? Which is adjacent. This place is adjacent and this is the hypotenuse, right? So I'm going to draw a right angle triangle. So this is my theta, or angle 90. This is square root of 13 and this is x plus 4. So we have to find this place. Let's see y. So from Pythagoras theorem, hypotenuse squared equals to opposite squared plus adjacent squared. So the hypotenuse is x plus 4 squared equals to y squared plus square root of 13 squared. So x plus 4 squared equals to y squared minus plus square cancel out the square root, y plus 13, right? So you say y squared equals to x plus 4 squared minus 13, right? So we say y equals to the square root of x plus 4 squared minus 13, right? So for you to find tan theta is the opposite of adjacent and opposite is y. So y is equals to x plus 4 squared minus 13 over the adjacent, which is square root of 13. So the value of our integral now is ln sec theta x plus 4 over square root of 13 plus the square root of x plus 4 squared minus 13 over square root of 13 plus c. This is the answer to our question. Integral of 1 over square root of x squared plus 8x plus 3 is this. So thank you for watching.